Going to demonstrate my application now. In the left panel, it displays the real-time screen capture of my mobile application, and the right panel is displayed in the right side. It displays the issuer host or the simulator of the bank which receives the ISO 853 its standard transactions. So I'm going to perform a transaction from my real mobile. So I will initiate a transaction of 1,000 rupees. I'll proceed with this, and we can, in this screen, we can enter the mobile number of the customer. This is an optional step, but if the customer enters based on the use case, and if the customer enters his mobile number, then it will enable of, if possible, it enables of granting discounted amount if he or she has bought enough, he has performed enough number of purchased in his purchase history. So I will proceed this. Based on his purchase history, the application says he has a 10% of discount, and the saving is 100 rupees and his base value is 900 rupees. In this section, it displays the reason for getting of such a discount. This discount is applied because you have purchase amount exceeding or equal to 40,000 rupees for the last 30 days. So I will proceed with this. Now the card is reading. As you can see in the right panel, the transaction is completed. Now I am entering the customer signature, and you can check the reports. And in the last entry, you can see that the 900 rupees discounted transaction is completed. So the important thing is that the discounting process is fetched from the backend, which is written in Node.js. So as you can see, I can show you the calls, and this is the last call which I performed with get reports, and this is the last push transaction. This is what gets called when we perform the get discounting process. So basically that's all for the application features. The one thing is I am not able to display the integrated hardware device. I will demonstrate it in another video snippet in the hardware integration part.
So this is to demonstrate the external hardware integration. Actually, in this, as it was stated in the document, and it was confirmed by you in the lecture, it was confirmed that the external hardware integration is okay. So I integrated the external Minifos device, which is provided by the DSpray. This is totally compliant with the EMV standard and certified device and a secure device. So this integration has happened over the Bluetooth CQ connection. So I'm going to perform the transaction with the integration of this device. So this is the customer discount. So I will proceed with this. The card is reading. Sorry for the low quality of the text is being displayed. And the transaction is completed.
Thank you.
The device. So this is the device which I have integrated. Because of the monochrome display, it's hard to video records what's being displayed while the transaction is being performed, because when the light is on, that's quite blurred. We can't see the detail properly.
So now I'm going to demonstrate the offline capability. I'm launching the app. As you can see, the no network is connected, the Wi-Fi and the mobile data. So there is a policy has been set in the application, which is that the transaction values above 1,000 rupees are not allowed to perform when there is no network. That means the transactions are not allowed to perform when there is no connection with the bank, when there is no approval process from the bank. So only the transaction value below 1,000 rupees are allowed to perform when there is no connection to the bank. So I'm going to demonstrate the first case, which is above 1,000 rupees. I will enter 1,500 rupees and attempt to perform a transaction.
Unable to connect, transaction terminate.
So as you can see, there is a voice engine is integrated into the mobile application. It says that unable to connect, transaction is declined because the transaction value was about 1,500. Now I'm going to perform a transaction below 1,000 rupees.
Enter the amount. Transaction approved offline.
As you can see, when the transaction value is below 1,000 rupees, which was 500 rupees, the transaction approved offline. That means the transaction is saved in the database offline. So let's switch on the connection to the issuer host. So as you can see, all the offline transactions have been synchronized to the backend as well. So now there is the particular transaction available in the backend. So to verify that, you can check the transaction with performed. This is the last transaction I performed, which is 500 rupees. So that is the offline capability demonstration. I will explain the code base now. So this is the code base. In the communication library, I have defined two classes, which is one is the network monitor and the one is the offline synchronizer class. The network monitor, basically what the network monitor does is it sends the current network status of the mobile application. This class is capable of detecting whether there is a communication or connected or the communication loss. So this is a totally decoupled class from the other rest of the code. So the whole job is to identify whether there is a connection or not. So there is another class, offline synchronization, which has aggregation relationship with the network monitor class. So the offline synchronizer class can register an event to get notified about the network connections. When there is a network connection available, this callback is connected with the connected enumeration value. So when there is a connection, there is a specific thread is run to push the transaction to the reporting backend, as well as to the issuer host. So this is the code snippet that is run when there is a connection is detected. However, when the actual transaction happens, when there is the unavailability of the connection has to be detected. So in order to explain that, this is how we define a transaction within the application. There are a couple of basic actions which has to be performed. So for example, we have to enter the amount, and we have to enter the card and a reading process, and it's a quite complicated process, and we have to send the transaction online, acquire the electronic signature from the customer, and so on and so forth. So whenever there is no transaction, whenever there is no network for the transaction to complete, within the action pay online, action pay card operations, it is detected. So once it is detected, there's a callback for this whole framework. This callback gets called whenever there is an important event is happened within the framework. So whenever the card transaction is process finished, it gets called back with this state. So we catch that state and we check for the result of the transaction, and particularly this. And whenever the transaction is not successful, that means the transaction is terminated. As you can see in this comment, that indicates the unavailability of the network for the particular transaction. And if that transaction is below the offline permitted amount, then the transaction is approved and saved in the database. Otherwise, the transaction is declined and transaction is finished in both cases. So that is the code demonstration for the offline capability. Okay, now I'm going to demonstrate and explain. Basically, it's going to explain the code which involves this external hardware integration. So in this, I have worked out a specific framework which is unique to this application in order to promote code extensibility and code manageability. So this is how the framework works, because whenever we are defining a transaction, the transaction can be sale or refund or cashback or void or whatever the type of transaction. So whenever we define a transaction, there is a bind action which has to be performed. Within that bind action, you can bind several actions which has to be performed while the transaction is being performed. So basically, there is enter amount, reading smart card, credit card or debit card, and sending transaction online, then acquiring the customer signature. Within each action, there's a complicated process could happen or a simple process could happen. It doesn't matter. The process is abstracted within the action class. So the defining a transaction is very easy with this framework. However, keep that aside. This is the action which is responsible for interacting with the external hardware device. So if you go into this class, we have this action record which is deriving from the action class, which is the base class of this. Every action should have a process. So this process gets executed when the particular action is executed. So within that, I have set it to run in a background thread. This background thread is spawned in the thread pool which is started while the application is initialized. And within that thread, we connect to the device. We connecting the device with the provided SDK. This SDK is provided by the device vendor. This is the SDK provided by the device vendor. However, once the device is connected, we pass the main thread handle into the device SDK, and we need to pass another listener interface, which has been defined by the device vendor. Once the transaction is initiated, there are a couple of callbacks gets called back into this callback interface. There are a lot of interfaces which is callbacks using this, as you can in the left panel. There are a lot of callbacks from the device SDK. We have to implement what we needed for our task. There are a couple of callbacks we have to implement for the compulsory transactions. So that's all for the external hardware integration. I'm going to demonstrate the components. Actually, in fact, I really don't understand what is meant by the component within the native Android, but if it was in React Native, I could have understood well what is the concept of component. But however, I will explain the framework. Within the framework, all the components, if I assume that those are the components, all components are reusable. I will explain the framework a bit to demonstrate the components within the applications. So there's basically a transaction. We have the primary objective of performing transactions within the application. So one of the main component of this framework is base transaction, which provide the basic means for the transaction, the starting of the transaction, ending of the transaction, and execution of the transaction. Whenever we define a transaction, we can derive from the base tran, which provide the base framework for the particular transaction. Within a transaction, we can define different actions within a transaction. So the framework provide this bind method, so we can bind a particular action to this state. So at the end of binding, so this bind action is called whenever the transaction is executed. So at the end of the binding, we call one of the bound state as we prefer. So in this case, if the transaction amount is already set, so we don't call that. Otherwise, we call the enter amount transaction, which in turn calls the enter amount activity to get the user input amount. So that's how this will work. It works as a finite state machine. So this is so whenever the particular action is performed, the action result is called back here. So this is the state particular. This is the particular state which is being executed, and the result of the action. So based on this state and the action, we can take actions. We can perform actions. We can direct the application to another state, and we can end the transaction. Do whatever we like. These are the basic components of this application. So there are a lot of other computation. This is a complete complete payment application. There are a lot of other components. But I wanted to demonstrate the framework I have particularly developed for this application. Okay, now I'm going to demonstrate the proof of the offline record. So I'll turn off the internet. This is the application. The internet is turned off, and I will perform a transaction which is below 1,000 rupees.
Looking for a device. Transaction approved offline.
The transaction is approved offline. Now I'm going to turn on the internet. As you can see that the offline transaction is synchronized with the backend. Now I'm going to uninstall the application. Application is uninstalled. I'm going to reinstall the application. This is the application, and I'll check the amount of the transaction which we perform, which is a 500 transaction amount. And I'll check the report. As you can see, the transaction record is persistent in the backend, and which we have fetched from the new application, which is 500 rupees. That proves the offline record is persistent in the backend and can be synchronized back into the front. So this is about constraint design principles. So we understand, one of the main energy dissipation problem is the display. So in the payment application, although it is not extensively used, the application is not using the display extensively. So I have tried to use the dark colors, since the dark colors uses less energy from the battery to display those pixels. So on the other hand, the device is integrated with external hardware, which is the information is conveyed through a secure Bluetooth connection. In the traditional setup, once the device is connected, the connection is persistent, which dissipates the battery. So in this application, I have set to disconnect each and after every transaction completion. So whenever transaction is initiated, a new transaction is new connection is established. That's all for the constraint device principle which we have implemented in this application.